In this video, we're going to prove the constant multiple rule for sequences. If you come to know that the limit of a sub n is a and k is any real number, then the limit of ka sub n is just k times the limit of a sub n. Remember, another way of writing a is, so I wrote k times the other way of writing a. So basically, the k comes out in front, and that is what we need to prove. So the limit as n goes to infinity of a sub n equals a, why that tells us that given any epsilon greater than 0, there does exist a natural number, an n, in the natural numbers, such that whenever n is sufficiently large, that is bigger than capital N, we have that a sub n minus a is going to be really small. It's going to be less than epsilon. You give me an epsilon, I'll give you an n. You give me a smaller epsilon, most probably I'll give you a larger n. Definitely not a smaller one. I guess I can also give you a smaller one. Okay, so now what is going on here? You have the limit of a sub n times k times a n. You want this to equal to ka. This is what you want. That is, so you have this if and only if the following true. Given any epsilon greater than 0, there exists an n, which we don't know if this n exists. There exists, say, an n1, such that whenever n is bigger than n1, k times a n and k times a, their difference is small. K times a n minus k times a, this is less than epsilon. Okay. But this statement implies that k times a n minus a, I should put the k in absolute values, this is less than epsilon. But that means dividing by the absolute value of k, this means that this difference is less than epsilon over the absolute value of k. Well, if I let epsilon equal the absolute value of k times another epsilon, well then I get epsilon. Because the new epsilon is replaced with k times another epsilon over the absolute value of k. That cancels out, and this gives us our epsilon. Okay. But that was true for, let's find it. That was true for n. That was true for n. We can just let n sub 1 equal n, or n sub 1 can be larger than n. And that would guarantee that this statement is true. So, given any epsilon greater than 0, there exists an n, this n, such that whenever n is sufficiently large, we have that k times a n minus k times a less than epsilon. That's exactly what we wanted to prove, and that completes the theorem, or the proof of the theorem. If you like these videos, leave a positive comment. Tell me how much you like them. If you don't like it, fine. Tell me how much you dislike them. Most of all, tell me what you think of these videos. If there's any theorems that you would like for me to prove, put them in the comment section. Most of all, watch and learn.